Earthquakes are a sudden shaking of the Earth's surface. They are caused by the movement of tectonic plates beneath the Earth's crust. The surface in which tectonic plates slip is referred to as the fault plane. In 2010, an earthquake with a magnitude of 8.8 on the Richter scale struck Chile on Saturday, 27th of February at 0334 local time, lasting a total of 3 minutes. According to official sources, 525 people lost their lives, 25 people went missing, and about 9% of the population in the affected regions lost their home, all in the space of 3 minutes. The earthquake's losses to the economy are estimated to be between 15 and 30 billion US dollars. The earthquake took place along the boundary between the Nazca and South American tectonic plates and was caused by the subduction of the Nazca plate beneath the South American tectonic plates. The movement of tectonic plates releases stored energy, producing seismic waves, causing mass destruction on the surface above.
During an earthquake, structures experience lateral forces which causes them to collapse. Engineers face challenges of generating buildings which are strong enough to resist the lateral forces caused by seismic movements. Engineers need to build with simple designs and avoid irregularities in buildings, as it will decrease its ability to withstand the lateral forces, thus reduces the time needed for people to escape from the building. Regular and continuous reinforcement is also equally important to prevent soft stories that are more likely to collapse during an earthquake. Take for example the O'Higgins Tower in Chile that experienced partial collapse due to soft stories in the 10th, 14th and 18th floors. Strong joints and firm connections help reduce the damage inflicted by earthquakes too.
During the 2010 Chile earthquake, 5 tailing dams failed, and the most crucial case was the collapse of the Las Palmas Dam. Problems arise because of the downslope movement of the tailings. When the underlying tailings got liquefied because of water-poor pressure, the coverage could not maintain stability anymore. Hence, a tailing flow occurred for about 0.5 kilometers, killing 4 people. To prevent losses of lives and properties, engineers need to check whether the safety factor of a slope is appropriate for each type of structure for the worst condition of soil.
Transportation engineering is an important factor of earthquake engineering. On macro, on damaged bridges, highways and ports supports disaster relief. On micro, a good evacuation plan that includes crowd management, fast routes, clear signs and effective safe zones will save thousands of lives. A successful crowd management plan will ensure civilians and cars are never mixed together, and that the civilians understand the appropriate evacuation route to their allocated safe zone. For example, the Chilean National Stadium has to evacuate nearly 50,000 people in under 8 minutes.
People are not harmed by earthquakes themselves. A few minutes of vigorous shaking may cause great discomfort but will not cause death nor injury. Death comes about from structures and buildings within an urbanization collapsing and failing. These structures are designed and built by engineers. These engineers are essentially responsible for the lives and well-being of populated settlements.